My name is Arman.
And my name is Bill, and today we'll be doing an investigation into DDoS techniques and their implications in 2024. To start off, we're going to be talking about what a denial of service is, we're going to explain and talk about what DDoS is, and then we're going to talk about the impacts as well as what motivations people might have to commit these kinds of attacks. We're then going to delve into some real-world cases where these attacks were carried out, how they were carried out, as well as the impacts that they caused, and then finally, we're going to be talking about some of the takeaways that we've learned since these attacks have happened. And then we're going to wrap up with our thoughts and conclusions of what we think next steps are as we continue to advance into the future.
So let's start with the introduction and give some context on denial of service attacks. So what is a denial of service attack? A denial of service attack is a cyber attack that prevents an online service from operating as it normally would, typically by flooding the service with requests until it can no longer process requests. You can imagine that a service, say Amazon, has a certain operating capacity. They have a certain number of servers, and those servers can handle so many requests at once. In theory, it would be possible to send so many requests to the Amazon servers that they can no longer serve new requests until the old ones are completed. A denial of service attack does this maliciously, sending fake requests to servers, overflowing them until they can no longer process requests from real users that are actually trying to use the servers. Now, what is a DDoS or distributed denial of service attack? The main difference between a DDoS and a DOS attack is the fact that a DOS attack will typically be carried out from one machine, whereas a DDoS is carried out by many machines, hence the distributed. This can be done if the attacker has many machines of their own, but it is more commonly done with what is called a botnet. A botnet is essentially a web of computers that the attacker has hacked or claimed for themselves, and they're going to use to spam the victim, or the server in this case, with fake requests. This makes the attacker hard to trace back, as each hacked machine is making requests from a different unique IP address, and it makes it difficult for the victim to find out where this DDoS attack is coming from in the first place. So DDoS attacks have been around for a long time. You would think that there have been countermeasures to them up until this point, and there have. As time goes on, more and more ways to counteract DDoS attacks are created, but at the same time, hackers are coming up with more and more ways to create more effective, efficient DDoS attacks. This graph seen here is from the Cloudflare DDoS threat report for the 2023 fourth quarter. It shows the largest DDoS attacks by HTTP request per second per year. We can see that in 2023, the largest HTTP DDoS attack was at 201 million requests per second, compared to in 2022 when it was only 26 million requests per second. You can see the significant jump here, and despite the fact that DDoS has been around for such a long time, it's continuing to evolve and become even more and more deadly. Now, what motivates people to commit DDoS attacks in the first place? There's many reasons for this. One of them that we can see in this graph is for political reasons. On the x-axis, you can see time, and on the y-axis, you can see the number of hourly DDoS requests before and after the Hamas attack in the Israel-Palestine conflict. You can see that after the attack, the number of DDoS requests in both regions spike up all of a sudden. People do this as a way of protest, rebellion, and etc. in political standpoints. Of course, this is not the only reason. There's many other reasons for this, such as personal reasons, grudges, reputation gain, etc. People may want to prove their own technical prowess or improve their standing in the hacker community. This is one example that we're going to see in one of the real-world examples that we're going to talk about. There's also financial gains. People may act as hackers for hire, where people will hire them to carry out DDoS attacks for their own reasons. There may also be blackmail, where a hacker will carry out DDoS attacks, threatening the company that they're attacking to give some sort of compensation in order for them to start. And also disrupting competitors. There's also the idea of a smokescreen or acting as a distraction. A DDoS attack may be carried out to take away the attention of engineers, while a more serious attack is carried out, such as breaching private data of a company. And lastly, there's also the concept of cyber warfare, disrupting the operations between governments, terrorist organizations, etc. What are the impacts of DDoS attacks? Well, depending on the context, it can mean many different things. If you look at the context of, say, a business being ran, every second that the business is down, it can result in a loss of revenue. If people can't access Amazon, they're not able to buy items on Amazon, causing Amazon to lose revenue for every minute that it's down. There could also be downtime in more critical services, such as banking or government websites, which people require to do some very fundamental aspects of their life. Not only can the company lose revenue during the time it's down, but there's also time and financial costs of recovery, putting in new measures to counteract the attacks that were done on them and getting their servers back up and running. And as we mentioned before, it also leaves these businesses more vulnerable to more severe attacks if the DDoS is used as a smokescreen, where the attackers may go in and steal valuable private information. So we've discussed the basic idea of a DDoS attack, some of the motivations, and the impacts it can have. Now, let's go into some of the more technical ways that these attacks are actually carried out. There's many different ways. I'll give a baseline example of a few here. The first is an application layer attack. This kind of attack exhausts server resources by flooding requests at the application layer. In this example, we see what is called an HTTP flood. It's fairly straightforward. The attacker will use their various different clients, bots on the botnet, etc., to spam a server with many HTTP requests. For the client to make this request, it's very cheap. You just request the file at the server. But for the server, it may be more costly. They need to run some algorithms to determine what HTML content to return to the user. They may need to run some database queries. And as a result of all these requests, the server may lose all their resources and not be able to serve new users. There's also the concept of a protocol attack. These kind of attacks consume server resources by abusing protocol weaknesses at the transport and network layer. The diagram we see here is an example of an SYN flood, which abuses the TCP protocol. We know that in a TCP handshake, the client first needs to send an SYN packet where the server will acknowledge it and then expect an acknowledgement back from the client. In this case, the attacker may use their bots to send many SYN or synchronized packets, and then the server will acknowledge these requests and wait for the acknowledgement back from the client, keeping the connection open. However, the attacker will not acknowledge the server's acknowledgement, leaving many connections open while the server waits for acknowledgements, eventually using up all the resources and not able to accept new TCP handshakes. The last attack that I'll talk about for the introduction here is a volumetric attack. The goal of this type of attack is to consume all the available bandwidth between the target and the larger internet. In this case, we have something called a DNS amplification attack. What happens here is the attacker spoofs the IP of the targeted victim with its bots. In other words, it's sending requests to DNS resolvers as if it's the target. It'll send a request to the DNS resolver, which results in the resolver sending back a large amount of information to the target. The operation of sending a request is cheap, but it returns a large amount of information to the targeted victim, which it was not expecting, flooding up the bandwidth.
So now that we know how a DDoS attack works and as well as how some are carried out, we're going to be diving into some real-world examples of three notable DDoS attacks that have happened, as well as what we have learned from them since. So to start off, we have the 2000 Mafia Boy attack, where he employed botnet flooding. As previously mentioned, botnet flooding is where essentially you take over a network or a number of different other devices and then use them under your control. So in 2000, the internet was still somewhat new. There were no firm cyber laws yet that existed, and there was a 16-year-old hacker in this group called TNT, who essentially wanted to help improve his ranking within his own community and sort of see what he could do with the tools that he had at his disposal. Essentially what he did was he overtook university networks that were not secure at the time, but by taking over these networks, he essentially had access to the fleet of computers that were provided at any university institutions that he hacked into, and then commanding them from a remote location where he could control the service and actions that these devices conducted. So essentially, what he did was he targeted specific servers. At the time, the notable ones were Yahoo, eBay, CNN, and Amazon. Yahoo being one of the biggest search engines at the time. But essentially, what he did was he overwhelmed all of these servers with massive amounts of queries from his botnet. And as these requests started to pile up over time, they drew away the bandwidth and resources for these servers, essentially causing lots of downtime as well as even server outages for a lot of these companies. And so what essentially happened was in the aftermath were hundreds of millions of dollars in damages, partially, as mentioned earlier, from the decreased amount of revenue for the time of the attack. But more importantly, there was a massive loss of customer trust as people now realized that these services that they thought were so essential could be at the vulnerability of DDoS attacks, where essentially their service is no longer operational. This obviously, led to decreased stock value for the respective companies. And what did this hacker gain out of this? Was there fame, recognition? He did gain more recognition within his hacker group, but at the time, there were other law enforcements that were notified about his activities and eventually tracked Mafia Boy down to find out who he was, where he was, and press charges eventually. At the time, in this sort of scenario, there were no very strict cybersecurity laws, and this whole situation eventually did lead to the development of more rigorous cybersecurity laws to prevent and discourage future bad hackers, and even led to the introduction of certain bounty programs, where essentially you have, instead of black hat hackers who are hacking for financial gain or personal reasons, these white hat hackers are essentially now hacking in favor of these companies to help bring exploits to light before they're publicly deployed in a live environment. And overall, this entire situation back in 2000 helped drastically raise the awareness of DDoS attacks. At the time, people weren't as familiar with how the internet sort of operated, and the exposure of such a massive attack on such a massive scale kind of opened people's eyes to the importance of having strong cybersecurity within their companies and within their servers. So to prevent these kinds of botnet flooding, there's a variety of different factors that we can employ, such as improving our local security through introducing firewalls, introducing intrusion detection systems, as well as conducting security audits. So in the example of the university, having all of these systems in place would help prevent future hacks from happening. From a higher level, the network providers can monitor network traffic to help detect suspicious activity, filter and reroute suspicious activity, as well as introduce automated rate limiting to prevent certain specific bots from continually having access to bombard certain servers. A final strategy that a lot of people now employ is using third-party services. So this can range from cloud protection to using services that essentially help cover your servers, using traffic monitoring and detection and rerouting those to sort of prevent those attacks from getting through. And the reason that this is more widely used now for larger companies because of how well it scales. So next we're going to look and explore the 2016 DYN attack. And this was conducted using an Internet of Things hack, where there was a virus called Mirai, which is Japanese for the word future. But essentially what this virus did was it infected IoT devices. So Internet of Things devices can range from anything from cameras to smart TVs, radios, printers, or even baby monitors. But essentially anything that has software and a connection to the internet was an Internet of Things device that was susceptible to this. So what Mirai did was exploit the weak security that was implemented and even today still implemented in a lot of IoT devices. And with these devices, they essentially become zombies that a hacker then can remotely control to conduct DDoS attacks on a victim. And these attacks would then also all come from unique IP addresses, which we'll get into later on, but it essentially makes it much more difficult to identify and track down where and how these attacks are being conducted. So as earlier mentioned, this is a botnet and how a botnet conducts a DDoS. But essentially in this case, what happened was all of these Internet of Things devices, such as printers, TVs, security cameras, even fridges, essentially became hosts of the Mirai malware that helped conduct these attacks. And in the end, DYN, as a host of numerous different platforms such as Airbnb, Amazon, GitHub, HBO, Netflix, PayPal, Reddit, and Twitter, just to name a few, this caused to the slowdown and even outage and downtime for a lot of these services. And essentially what was happening was these companies were still operational because their own servers and services were still up. But what was down was DYN's domain name server. And because this server was down, it was unable to resolve people's requests for host names. And because they couldn't resolve the host names, they couldn't connect them to the services. Obviously, when you're requesting Amazon.com, you don't type in the address of Amazon, but you request them by their host name. And because this domain name server was down, many different services were down as well. And this kind of led to DYN working with ISP providers to filter traffic, work on rerouting strategies, as well as immediately patching these vulnerabilities so that they could alleviate the attack. And this kind of helped them manage it, under an hour. But in order to mitigate these attacks in the future, this kind of comes down to designing the devices for IoT with security in mind, and this kind of comes down to the manufacturers and programmers to consider security as a core fundamental aspect when designing these. As well as for the distributors, they can continue to support firmware updates, as this would offer more prolonged support for IoT devices to patch any future exploits that are discovered. But obviously this is limited by the device and the physical hardware that exists, so keeping those up to date can be a challenge as we move into the future. On a personal level though, users can make sure that their home networks are secure and ensure that the devices that they do have strong firewalls and passwords, and continually updating devices to make sure that they are up to speed on the best prevention methods. Lastly, we'll take a quick look at the 2018 GitHub DDoS attack, where a hacker essentially continued to use a DDoS attack, but employed a memcache, took advantage of a memcached server. So botnet, as we previously explained on how they work, but the difference in this case was they used a memcache server where they spoofed requests from acting as GitHub, and these servers would then return massive amounts of data to GitHub to sort of overload GitHub servers. And at the peak reaching 1.3 terabytes per second or 120 million packets per second. So what is a memcache server? Essentially what a distributed memory caching server is normally it would help speed up websites and apps by caching the frequently accessed data in RAM to reduce backend load. But in this case, since they were hijacked, what a hacker could do is spoof as a certain victim and make certain requests. And from these requests, these servers would then overload the victim with the requests. In this case, it was done through UDP because there was no IP validation. But essentially, to sort of graphically show what happened was a hacker can make a request to these memcache servers acting as GitHub. And then GitHub, these memcache servers will then requesting these massive files, will then send it back to GitHub, overloading their servers and their capacity to handle them. So through this amplification, they couldn't handle these spoof requests and essentially making them unusable. So in the aftermath, what did GitHub do? GitHub had a third-party service that helped detect and redirect the traffic away using advanced filtering algorithms. Because of their quick response, the outage only lasted 20 minutes. Because of the large volume, they were kind of notified immediately. But in the future, how can we secure these memcache servers? So some strategies would be to allow server admins to make sure that only necessary things are connected to the server, as well as rate limiting to prevent massive responses from a single IP source, as well as disabling unused or unnecessary services and protocols, for example, in this case, using UDP for memcache servers. So what can we do now? After taking a look at all these examples, what we can do as engineers is we learn and improve.
So we talked about some DDoS techniques, but that's only a drop in the bucket. We saw HTTP flood attacks, SYN flood attacks, and DNS attacks, but there's many other examples, such as other protocol attacks, such as the acknowledge flood attacks, as well as low and slow attacks, which gradually increase the number of requests to avoid some rate limiting alarms being set off, as well as very new styles of attacks, such as cryptocurrency, which disrupt cryptocurrency blockchains.
Some other notable DDoS prevention techniques we had are reducing the attack surface, so using load balancers to help distribute sort of the load that you get, using an anycast network diffusion, which does the same thing but on a wider scale, threat monitoring to make sure that these spikes in traffic are detected and alleviated, using CDNs to cache and redistribute frequently accessed content to make sure that not all the load is being put on one main server, using rate limiting, as we previously mentioned, to make sure that backend endpoints are well protected from certain requesting IPs, as well as using third-party services such as Cloudflare, Akami, Impervia, Radware, and Arbor. And using all of these together, you can help create a much more safe and reliable network experience.
Now we'll go into the conclusion, where we'll quickly review some of the content that we talked about. Oops, sorry about that. So today we talked about what a DDoS is and some of the ways they're carried out, the motivations and impacts of DDoS attacks. We covered 3 real-world examples, ranging from very early on, where there was a lack of cybersecurity awareness, some more unique attacks where we exploited IoT devices, as well as an attack where even though a very unique method was employed, we saw how correct preventative measures can counteract even these unique attacks.
So what are our takeaways from all of this? All we have noticed that from these case studies is that they can be extremely devastating for both services as well as the users themselves. And with the ever-evolving landscape of the internet, DDoS attacks continue to be on the rise in terms of being a tool that hackers can use to disrupt services. For example, the discovery of this memcached exploit that was used on the 2018 GitHub attack. And this kind of just reiterates the necessity for having strong cybersecurity implemented into your business. It's kind of important to consider that not only can you help prevent DDoS attacks, but to consider all aspects of cybersecurity as you continue to develop your business, especially if your business or company kind of serves an essential purpose. For example, like financial institutions, government institutions, things that are much more essential to people's lives as opposed to, for example, GitHub, which is still very important, but not as dire. So keeping these in mind, always having strong cybersecurity to prevent these kinds of attacks is essential as we continue to move forward in the world. And finally, here are the references that we used for this presentation. We hope that you enjoyed and learned something about DDoS, and
we're looking forward to your questions.
Great.